Hi friends, today we are going to start our new subject called Mechanics of Materials. Mechanics of Materials, and which is denoted by MOS, and this is also called as strength of materials. Strength of materials, and which is denoted as SOM, or it is also called as mechanics of materials. Okay, mechanics of materials is denoted as MOM. Okay, as the name suggests, and this is a branch of mechanics. So, what is this mechanics? And mechanics is a branch of science that deals with the forces and its effects on bodies in which it acts. Okay, so that's the branch of science which is called the mechanics. And this mechanics is further classified into three as statics. Then we are having dynamics, and also we are having a classification called mechanics of materials. So please don't get confused. Let me complete this first. These subjects, statics and dynamics together, called the engineering mechanics, that we have that not coming into picture right now. So the subject that the remaining subject, which is nothing but mechanics of materials, and that is further classified into two based on the type of materials, that we are having the solid materials, and also we are having some fluid materials, and we are not concerned about the other classification of materials right now. So the subject that deals with the mechanics of solids is simply called as mechanics of solids, or strength of materials, or mechanics of material in a general term. And the subject that deals with the mechanics of fluids is called the fluid mechanics, which is here from. So here comes a small doubt that in the subject of strength of materials, or in the subject of strength of materials, we are dealing with solids, and also in the engineering mechanics we have dealt with the solids. So what is the difference? What is the difference over here? So let me resolve it. We know that in the engineering mechanics we have dealt with certain bodies. Remember certain problems in the engineering mechanics, that we are having a body like this, which is placed on a surface like this, and upon action of certain force, or upon application of certain force F, and the way it moves, that is the geometry of its motion, which is governed by the dynamics, or the equations of dynamics, and whether it is moving or not, whether it remains stationary at a particular force, which is given by the equations of statics. So that happens in the engineering mechanics. So here what happens is that we are having, or we are limited these studies to a particular type of bodies only, and those bodies are called the rigid body. So this body is called the rigid body. So you remember rigid body, what it is? Rigid bodies are not some bodies which are having two points like this, A and B, on its surface or in the body. We know that upon application of any amount of force on this particular body, if the distance between these 2 points remains same, then such bodies are called the rigid bodies. Such bodies are called the rigid bodies. And if you are having some body in which this d, that is the distance between these two, the same 2 points considered upon the application of force, is no constant, and those type of bodies are called the deformable bodies. Okay, so that is the classical or the fundamental difference between this engineering mechanics and the strength of materials. That is, in the strength of materials, we are dealing with some bodies called deformable bodies, but in the engineering mechanics, we are dealing with the bodies called the rigid bodies. And we have seen in this particular example, the example that I told, what happens is that we are considering only the external effects on bodies due to forces. We are primarily concerned with the external effects that are happening on this particular body. Okay. Meanwhile, in the subject of strength of materials, what we are concerned is that, let's suppose we are having a body or a shaft like this. Let's suppose we are having a shaft like this, and upon application of some certain force F in this way, what we are considering is that, or what happens is that, as this is a deformed body, its length get increased, at the same time its diameter getting reduced. So we are concerned with the deformation. Okay, in this particular subject we are concerned about the how much is the deformation that is occurring, and also upon the application of these external forces, what is happening inside this particular body. Okay, so you may know that due to these forces some stresses generate within this material. You will be already studied those things, and these stresses are nothing but the internal resisting forces that are opposing these particular external forces. So in this strength of materials, we will be dealing with the deformations along with what are the internal effects that are occurring in this particular body, within this body. Okay, so this is the fundamental difference between our engineering mechanics and the strength of materials. And from today onwards, or from this lecture onwards, we will be dealing with the strength of materials, the deformations and the internal effects that are occurring on these certain bodies upon various kind of loads. Okay, so that's it.